Eric Schmidt takes the helm, aiming for orbital success with Relativity Space's Terran R rocket by 2026. On March 10, 2025, Relativity Space made headlines as it announced the appointment of Eric Schmidt, the former CEO of Google, as its new chief executive officer. This significant leadership change signifies a new chapter for the company, which is focused on developing cutting-edge launch vehicles, particularly the ambitious Terran R rocket. Leadership transition. Eric Schmidt replaces Tim Ellis, a co-founder of Relativity Space who had served as CEO since the company's inception. While Ellis will remain on the board of directors, his departure from the CEO role marks a strategic shift aimed at accelerating the development and launch of the Terran R rocket. Schmidt's involvement is not only a leadership change but also includes a substantial investment in the company, although specific figures were not publicly disclosed. Schmidt, who served as Google's CEO from 2001 to 2011 and as executive chairman until 2017, brings extensive experience in technology and innovation. His role on the Pentagon's Defense Innovation Advisory Board from 2016 to 2020 further emphasizes his capability in guiding Relativity Space through the complexities of the aerospace industry. The vision for Terran R. Relativity Space is recognized for its innovative approach to rocket manufacturing, primarily using additive manufacturing or 3D printing. This technique allows for a reduction in traditional manufacturing costs and offers greater flexibility in production. The company originally entered the market with the smaller Terran 1 rocket, which experienced a setback during its maiden flight in March 2023, failing to reach orbit. Following this, Relativity made the strategic decision to retire the Terran 1 in favor of focusing on the more ambitious Terran R rocket. The Terran R is designed to be a fully reusable launch vehicle, comparable to SpaceX's Falcon 9. Announced in March 2023, the Terran R aims for its first launch by late 2026. Since then, the company has reported significant progress in its development, having completed a critical design review and initiated production of flight hardware for both the first and second stages of the rocket. Engine development and technical progress. Central to the Terran R's success is the Aeon R engine, which will power the rocket. Relativity has been actively testing this engine, achieving impressive test durations exceeding 2,500 seconds. The Aeon R engine is designed to meet the demanding requirements of a reusable launch vehicle and is currently undergoing rigorous testing to ensure its reliability and performance. The company has also made mentions of its financial health, reporting a backlog of $2.9 billion in contracts. This backlog demonstrates a strong market demand for Relativity services, particularly as SpaceX maintains a dominant position in the launch market. Relativity's executives, including Imo Shahzad, president and CFO, expressed confidence in the company's technical development and its capability to deliver a commercially competitive launch vehicle. Market context and competitive landscape. As the commercial space launch market continues to evolve, Relativity Space is positioning itself as a formidable player against established competitors like SpaceX. The significant backlog of contracts signals a growing appetite for additional cost-effective launch services, especially for low-Earth orbit LEO constellations. Josh Brost, the Chief Revenue Officer of Relativity, emphasized that the Terran R is designed to occupy a sweet spot in the market, offering economic advantages that could attract a wide array of customers. The company's innovative approach to manufacturing and its focus on reusability could potentially disrupt the current launch market dynamics. Future prospects. With Schmidt at the helm, Relativity Space is poised for significant advancements in the coming years. The first launch of the Terran R is eagerly anticipated for late 2026, with the company working diligently to meet this timeline. As Relativity continues to innovate and refine its technologies, the aerospace community and potential customers will be watching closely to see if the company can fulfill its ambitious goals. In summary, Eric Schmidt's appointment as CEO of Relativity Space marks a pivotal moment for the company as it aims to establish the Terran R rocket as a leading option in the commercial launch market by 2026. With a strong financial foundation and innovative manufacturing techniques, Relativity is positioned for success in an increasingly competitive landscape. The announcement of Eric Schmidt's appointment as the CEO of Relativity Space on March 10, 2025 introduces several counterintuitive elements regarding the intersection of technology leadership and aerospace innovation. At first glance, Schmidt's background in software engineering and his tenure as Google's CEO might suggest a mismatch for a role in a rocket manufacturing company. However, this situation reveals the increasingly interdisciplinary nature of modern aerospace challenges, where tech expertise is becoming as crucial as traditional engineering skills. One counterintuitive aspect is the reliance on additive manufacturing or 3D printing, which Relativity Space employs for rocket production. While 3D printing is traditionally seen as a method for rapid prototyping and small-scale production, Relativity's commitment to using it for entire rockets contradicts conventional manufacturing wisdom. This approach is expected to streamline production processes and significantly reduce costs, challenging the long-held belief that aerospace manufacturing requires extensive and expensive traditional infrastructure. Schmidt's leadership might further accelerate this paradigm shift given his background in scaling tech companies. Furthermore, the narrative around the failure of the Terran R rocket, its maiden flight in March 2023 did not reach orbit, might suggest a setback for Relativity Space. However, the decision to retire the Terran R to focus on the more ambitious Terran R could be seen as a strategic pivot rather than a failure. This reflects a counterintuitive mindset where prioritizing long-term goals over short-term successes is deemed essential, especially in an industry where development cycles are long and costly. Additionally, Relativity's $2.9 billion backlog in contracts indicates a robust demand for its services, which is somewhat surprising in light of the competitive landscape dominated by established players like SpaceX. It suggests that the market is not only receptive to new entrants but is actively seeking alternatives, thereby challenging the belief that incumbents have an insurmountable advantage in aerospace. Schmidt's substantial investment in Relativity Space also raises eyebrows. It is unusual for a tech executive to pivot so dramatically from the software sector to aerospace, particularly when the latter is fraught with risks and uncertainties. This investment reflects a counterintuitive trend where successful technology leaders are diversifying their portfolios into industries that were once considered peripheral to their expertise. This trend could indicate a belief in the convergence of technology and aerospace as the two fields increasingly intersect, particularly in areas like satellite deployment and space exploration. Moreover, while the media reports focus on Schmidt's credentials and the potential impact of his leadership, they may understate the inherent challenges facing Relativity Space. The intense scrutiny and high stakes of the aerospace industry contrast sharply with the tech sector's relatively rapid iteration cycles. Thus, the confidence expressed by company executives in their ability to deliver the Terran R by late 2026 might seem overly optimistic given the historical difficulties in launching new rockets. In summary, the appointment of Eric Schmidt as CEO of Relativity Space symbolizes a significant shift in the aerospace landscape where technology and innovation are increasingly intertwined. The company's strategy to leverage 3D printing, its pivot from the Terran R to the Terran R, and the robust contract backlog all highlight counterintuitive trends that challenge traditional notions of manufacturing competition and leadership in the aerospace sector. These developments could set the stage for a new era in space exploration driven by a blend of technological prowess and innovative manufacturing techniques. In the report regarding Eric Schmidt's appointment as CEO of Relativity Space, several key details stand out that may be easily overlooked but are crucial for understanding the implications of this leadership change and the broader context in which Relativity Space operates. 1. Significance of Schmidt's investment and experience. While much attention is given to Schmidt's notable career at Google and his new role, the significance of his substantial investment in Relativity Space should not be underestimated. This investment signifies not only personal confidence in the company's potential but may also attract further investment from others in the tech and aerospace sectors. Schmidt's background in technology, particularly in innovation and scaling businesses, suggests he could bring new strategies and insights that could transform Relativity Space's operational approach. 2. Shift from Terran 1 to Terran R. The decision to retire the Terran 1 rocket after a single unsuccessful launch may initially seem like a setback. However, it reflects a strategic pivot towards the more ambitious Terran R rocket. This shift indicates not just a focus on improving technology but highlights an understanding of market needs. The Terran R is designed to compete directly with established players like SpaceX, suggesting a long-term vision that acknowledges the competitive landscape of the launch market. This decision could be a critical turning point for the company as it aligns its resources towards a more promising and potentially lucrative project. 3. Additive manufacturing as a core strategy. Relativity Space's commitment to additive manufacturing 3D printing is a fundamental aspect that could be easily overlooked. This innovative approach is intended to reduce costs and increase flexibility in rocket production. It represents a significant departure from traditional aerospace manufacturing methods, which are often capital-intensive and time-consuming. The ability to produce components quickly and adaptively could give Relativity a competitive edge, particularly in a market that is increasingly demanding rapid turnaround and cost-effective solutions. 4. The financial backlog, demand signals. The reported $2.9 billion backlog in contracts is a significant indicator of market demand for Relativity services. This figure not only reflects the current confidence that clients have in Relativity's future but also underscores the urgent need for alternative launch providers in a market currently dominated by SpaceX. The backlog signals a validation of Relativity's strategic direction and could enhance its negotiating position with potential investors and partners. 5. Technological progress and milestones. While the report mentions that Relativity has completed a critical design review and has begun production on flight hardware for the Terran R, the specifics of these milestones are often glossed over. Achieving these milestones is crucial for maintaining momentum and confidence, both internally within the company and externally with stakeholders and investors. The successful testing of the Aeon R engine, which is planned to power the Terran R, is particularly significant as engine performance is a critical factor in launch vehicle success. These technical advances could enhance the company's credibility and operational readiness. 6. Competitive landscape and market positioning. The context of the broader space industry, including the dominance of SpaceX, is an essential aspect that may be underappreciated. The competitive landscape is evolving and the demand for reliable, cost-effective launch services is increasing. Relativity's focus on creating a commercially viable launch vehicle tailored for low Earth orbit LEO constellations positions it strategically within this changing market. This positioning is vital for attracting clients who may be seeking alternatives to SpaceX, which currently holds a significant share of the market. 7. Implications for future leadership in space tech. Schmidt's appointment could represent a broader trend of technology leaders from other industries stepping into the aerospace sector. His leadership may pave the way for more tech-driven approaches to problems traditionally faced in aerospace, such as long development cycles, regulatory challenges, and high costs. This could stimulate further innovation across the industry as other tech leaders may follow suit. Conclusion. Eric Schmidt's role at Relativity Space is not merely a leadership change, it is a pivotal moment that could reshape the company's trajectory in the competitive aerospace market. The interplay of his investment, the strategic pivot toward Terran R, the focus on additive manufacturing, and the substantial backlog of contracts all indicate a potential for significant impact on the commercial launch landscape. Understanding these nuances helps to appreciate the potential shifts in strategy and leadership that could influence the future of space exploration and technology. 1. Leadership transition and strategic vision. Eric Schmidt's appointment as CEO of Relativity Space signifies a strategic pivot for the company, moving from co-founder Tim Ellis to a leader with extensive experience in technology and innovation. Schmidt's background at Google and his involvement with the Pentagon's Defense Innovation Advisory Board suggest that he will likely leverage his expertise to enhance Relativity's technological advancements and competitive position in the launch market. This transition could bring a new vision for the company's direction, focusing on innovation efficiency and market responsiveness, which are crucial for competing against established players like SpaceX. 2. Focus on additive manufacturing and technological innovation. Relativity Space's commitment to additive manufacturing 3D printing is a core aspect of its strategy to revolutionize rocket production. By utilizing advanced manufacturing techniques, the company aims to reduce costs and streamline production processes. The shift from the failed Terran 1 to the more ambitious Terran R highlights this focus, as the latter is designed to be a fully reusable launch vehicle akin to SpaceX's Falcon 9. An in-depth analysis of how additive manufacturing impacts production timelines, cost structures, and overall rocket design could illuminate Relativity's potential to disrupt the traditional aerospace industry. 3. Financial position and market demand. With a substantial backlog of $2.9 billion in contracts, Relativity Space is well positioned in a market that is increasingly seeking cost-effective launch solutions. This financial backing not only indicates strong demand for the Terran R rocket but also reflects customer confidence in the company's ability to deliver competitive services. An exploration of the implications of this financial position, including how it can facilitate further research, development, and marketing efforts, would be valuable. Additionally, understanding the competitive landscape and the reasons behind the demand for alternatives to SpaceX could shed light on market dynamics. 4. Launch timeline and development progress. The ambitious goal of launching the Terran R by late 2026 represents a critical milestone for Relativity Space. Recent updates indicating the completion of a critical design review and progress on engine testing suggest that the company is on track to meet this timeline. A thorough examination of the technological challenges and milestones ahead for the Terran R, including the testing of the Aeon R engine and the production of flight hardware, would provide insights into the feasibility of the proposed launch schedule. Additionally, assessing how these developments align with industry trends and customer needs will be crucial for understanding Relativity's future trajectory. 1. NASA's Apollo program. The Apollo program, initiated in the early 1960s, was a landmark space exploration initiative aimed at landing humans on the Moon. Under the leadership of NASA Administrator James Webb, the program faced numerous challenges, including technical failures and budget constraints. The successful Apollo 11 mission in 1969, which landed astronauts Neil Armstrong and Buzz Aldrin on the lunar surface, marked a monumental achievement in space exploration, reflecting the importance of strong leadership and innovative engineering solutions. The program's focus on reusable technologies and incremental development parallels the ambitions of Relativity Space with its Terran R rocket. 2. SpaceX's Falcon 1 and Falcon 9 development. SpaceX, founded by Elon Musk in 2002, faced significant hurdles in its early years, particularly with the Falcon 1 rocket, which experienced multiple launch failures. After a series of setbacks, SpaceX successfully reached orbit with Falcon 1 in 2008, which set the stage for the development of the more advanced Falcon 9 rocket. The iterative design and manufacturing processes employed by SpaceX, including the use of reusability, mirror Relativity Space's approach to rocket design and production. Just as SpaceX revolutionized the launch industry, Relativity Space aims to disrupt the market with its innovative 3D printing techniques. 3. Boeing 787 Dreamliner project. Boeing's 787 Dreamliner project, initiated in the early 2000s, was marked by ambitious goals in fuel efficiency and advanced materials, including extensive use of composite materials. The project encountered significant delays and cost overruns due to complex supply chain issues and manufacturing challenges. However, under the leadership of then-CEO Jim McNerney, Boeing navigated these obstacles, ultimately delivering a successful aircraft that transformed the aviation market. This case is similar to Relativity Space's current position as both companies seek to introduce innovative manufacturing methods while managing the inherent risks of developing new technologies in highly competitive markets. Future outlook for Relativity Space and the Terran R rocket. With Eric Schmidt at the helm as the new CEO of Relativity Space, the company is poised for transformative growth in the commercial space industry. Schmidt's extensive background in technology and innovation, coupled with Relativity's unique approach to rocket manufacturing, creates a compelling narrative for the future of space exploration and satellite launches. Here are some predictions and insights into what we can expect from Relativity Space and the Terran R rocket by 2025 and beyond. 1. Successful launch of the Terran R by 2026. The immediate goal for Relativity Space is to successfully launch the Terran R rocket by late 2026. Given Schmidt's leadership and the company's recent strides in development, such as completing a critical design review and beginning the production of flight hardware, the likelihood of achieving this target is promising. If the company can maintain its momentum and address any technical challenges, the first launch could solidify its position in the launch market. 2. Increased market competitiveness. With a backlog of $2.9 billion in contracts, Relativity Space is entering a competitive phase against established players like SpaceX. The Terran R is designed to fill a critical niche for low Earth orbit LEO missions, particularly for satellite constellations and other commercial payloads. As demand for satellite launches continues to rise, driven by the proliferation of communication Earth observation and Internet satellites, Relativity Space's competitive pricing and innovative manufacturing capabilities could position it as a go-to provider for various clients. 3. Advancements in 3D printing technology. Relativity Space's unique focus on additive manufacturing is a game-changer. As they refine their 3D printing processes, we can expect significant advancements that not only streamline production but also reduce costs. By 2025, the company could further innovate in materials and manufacturing techniques, potentially leading to lighter, more efficient rockets. This could enhance the overall performance of the Terran R in future models. 4. Strategic partnerships and collaborations. Under Schmidt's leadership, it is likely that Relativity Space will pursue strategic partnerships to enhance its market presence and technological capabilities. Collaborations with satellite companies, government agencies, and research institutions could open new avenues for business and innovation. By leveraging Schmidt's network and influence, Relativity may secure additional contracts and partnerships that bolster its growth trajectory. 5. Expansion of launch capabilities. As the Terran R gears up for its debut, Relativity Space may also explore expanding its launch capabilities. This could involve developing additional variants of the Terran R or entirely new launch vehicles tailored for specific missions. If the Terran R proves successful, the company could leverage its technology and manufacturing expertise to diversify its offerings, catering to various sectors such as national defense, scientific research, and commercial space tourism. 6. Focus on sustainability and environmental impact. The space industry faces increasing scrutiny regarding its environmental impact. Relativity Space has the potential to lead in sustainable practices by continuing to innovate in fuel efficiency and waste reduction in rocket manufacturing and launches. By focusing on environmentally friendly technologies such as using cleaner propellants and reducing the carbon footprint of their operations, Relativity could attract customers who prioritize sustainability, enhancing its reputation and market appeal. 7. Navigating regulatory challenges. As Relativity Space aims for ambitious growth, navigating regulatory frameworks will be crucial. Schmidt's experience in both the tech industry and advisory roles such as with the Pentagon could provide a strategic advantage in addressing regulatory hurdles. By proactively engaging with governmental bodies and advocating for favorable policies, Relativity can facilitate smoother operations and establish itself as a trusted player in the space sector. 8. Potential for international expansion. Looking beyond the US market, there may be opportunities for Relativity Space to expand its services internationally. As more countries invest in their space programs and satellite capabilities, Relativity could explore partnerships or launch services in emerging markets. This expansion could further diversify its revenue streams and enhance its global footprint in the space industry. Conclusion: Eric Schmidt's leadership marks a pivotal moment for Relativity Space. With the ambitious goal of launching the Terran R rocket by 2026 and a robust financial backing, the company is well positioned to disrupt the commercial space launch market. By leveraging its innovative manufacturing techniques, focusing on market needs, and potentially expanding its offerings, Relativity Space could redefine space access in the coming years. The next few years will be critical in determining its success, but with the right execution, Relativity Space may become a key player in the future of space exploration and commercial satellite launches.